is all about slope. Hey, and you might say, well, we've already done slope, and you have, and we even did slope a couple days ago when I told you that when we graphed, I went ahead and started talking about slope a little bit just because we have already graphed using slope, and I think it's the easy way to graph, and I'm not going to make you do something harder if we've got an easier way to do it. And so I've already kind of briefly talked about slope. There's a lot of different ways to find slope based on what we're given, and so we kind of have to take what we're given, whether it's a table, ordered pairs, a graph, whatever it might be, and how do we find slope? Okay. The only time that we really find slope, though, is in a linear situation. Okay, and we're gonna have to talk about what does that mean for it to be a linear situation. Okay, but typically we use slope. Slope is something that you see all the time. You may not even know that you're seeing slope, right? Common things, you got like the pitch of a roof. The pitch of a roof on maybe your house at home is different than like the pitch of the roof for the school, but there's still a pitch. If you went on top of the school, because our school is so long, you wouldn't even think there's a slope to it, right? But when it rains out, there has to be a slope to it because they can get the water off of the roof and it needs to come down the downspouts, right? Otherwise the water sits up there, the roof caves in, and we got all kinds of issues. So there is slope up there, but sometimes you can't even see it by looking at it. Kind of like the roadway. If you're out driving on the road and there's like a really big heavy downpour coming on, then that water is sloping off of into the ditches, right? If that water was sitting on the roadway, then it would cause issues. And so there's slope, all kinds of different scenarios. Another one you might think of is like a handicap ramp going up the side of a building, okay? If I was a contractor and I had to build that, they give you like special specifications that you have to build at a certain steepness, okay? If you build it too steep, then it's gonna be really hard for the handicapped people that have to go up it, okay? And you're gonna have to do it all over again, okay? So when we talk about slope, there are definite times where slope has to be met to certain requirements. And that would be all kinds of examples of slope in everyday life, but those are just a couple things that I think about when I think about slope. All right, so it has to be a linear situation. I'm going to show you what that means and what that looks like. I'm going to give you a table of values here. We've got a bunch of points on here. Okay, in order to determine if this is a linear equation, there's basically three questions that we have to answer. Okay? The first one would be, is the change of x constant? And constant means remains the same, right? Is it the same all the way down? If it's different, it's not linear, okay? And so as I look at my change in x's, we're going up to, all the way down. So as long as we are going up by the same amount all the way through, then we've got a constant change. So my first question would be yes. Okay, second question. Is the change of y constant? Okay, it doesn't have to be the same as the change of x. It just has to be constant for those y values. So here we're going down 4, all the way down. And so we would say yes. Okay. And so then finally, the third question would be, is the function a linear function? If I answer yes to both of these, then we would say, yes, it's linear. And if it's linear, that means I can find the slope. So to find the slope of this table, all we would have to do is we're going to put the change of y over the change of x. And that would end up being -4 over 2. If I can simplify it, I would say this equation would have a slope of -2. We're not actually asking what the equation is or what would the equation look like. We just want to know what the slope of it would be. If I said no to any of these, then it wouldn't have a slope. I wouldn't have to do this part here. But that would be the quick and easy way that I could get the slope if I answer yes to all those questions. Okay, so that's kind of how we determine if we find slope or can find slope. The situations that we're going to be given today are going to be linear situations, because that's what this whole unit today, or this whole section today, is about, is slope, and finding slope a lot of different ways, and then doing some things with those slopes. Lots of different ways to find slope. We can find slope with 2 points. If I'm going to find slope with 2 points, we're going to use the formula. So here's another formula for us. y2 minus y1 over x2 minus x1. Okay, the other day we did the midpoint, we did the distance, and it had x1, y1, x2, y2, so it's going to be a similar scenario here. If I gave you 2 ordered pairs, I would go, and I should say, even though I think we probably know this, lowercase m is always used to represent slope. So anytime I see, we saw it the other day when we talked about y equals mx plus b, anytime we see lowercase m represents our slope. This is x1, y1, x2, y2. So we're going to go 10 minus 6 over 7 minus -3. So that gives me 4 over 10. And always reduce it. Our slope would be 2 over 5. If it reduces down to be like, let's say it was like 10 over 5, then I would just leave it as 2. Okay, you don't necessarily have to write it as 2 over 1. But usually a fraction is the best way to write slope, because a lot of times we refer to slope as rise over run. So especially when I graph, rise over run would be a quick and easy way to be able to do that. So leaving it as a fraction. Is it wrong to leave it as a decimal? Not really, okay? But there are situations and times where a fraction is much better than a decimal. Sometimes our decimal is like a big repeating decimal. We don't want to write slope, especially as a repeating decimal. If it was like 1/3, I don't want to write it as 0.3 repeating. I would rather write it as 1 over 3 for our slope. Okay, so fraction would probably be the better way to write it. The other day we talked about using slope to graph. We could do the same thing here. If I gave you 2 points, And I'm going to give you some different scenarios here. Let's start off with, I'm going to go here and here. Okay, I want to find the slope of this line. If they give me a graph like this, then finding the slope is just a matter of counting. Like we said just a second ago, we are simply just going to do rise over run. So when we do this, we're going to move up, and then we're going to move over. We got to find 2 points that are on that line in order to be able to do it. So in this case, we went up 1, 2, 3, 4, 5. And we went right 1, 2, 3, 4, 10. So here our slope would be 5 over 10, which would reduce to be 1 over 2. Okay, up 1 over 2. And what that basically means then is every time I go up 1 and over 2, there should be another point there, okay? And that's kind of what we did the other day when we graphed. There would be a bunch of points that would be on that line. So any 2 points on that line would help me to find that slope. Okay, the other thing I want to point out here is that this is a positive slope because it's moving up and to the right. Anytime a graph moves up and to the right, the slope will always be positive. The steepness will change, right? How steep that graph is, but it'll still be a positive number if it's moving up and to the right. So that's the first type of slope that we're going to see on a graph. We could also do a graph like this. So as I go from point to point here, I'm going to go down and I'm going to go over. So I'm going to go down 1, 2, 3, 4, and I'm going to go over 2. So my slope here would be down 4 over 2, which would be negative 2. Okay. This slope, as it goes down and to the right, is a negative slope. Okay. Once again, the steepness can change, but it's going to be a negative number if it's going down as it moves to the right. Okay. We know the sign will be negative. Okay, the other 2 slopes that we're going to talk about okay, if I have a horizontal line. Okay, if I have a horizontal line that's not going up or down, it's just staying flat, okay, staying constant. So here, what would my rise be? 0, right? It doesn't go up or down at all. So my rise is 0. I really don't care how far I move, left or right. But if you wanted to count and say, well, to go from one point to the next, I'm moving over 6. The reason it really doesn't matter is because if I have 0 on top, 0 divided by anything is always 0. Okay? So if you see a horizontal line always has a slope of 0 every time. Okay? It means there is no rise to that line. The fourth type would be a vertical line. Once again, if we have multiple points here, my rise is maybe 5. My run doesn't go left or right at all, right? There is no movement left or right. It just goes up 5. So we're doing 5 divided by 0, but we talked about this yesterday. Anytime I have 0 in the denominator, what's that mean? Undefined. We can't do it, right? So here we would say this slope is undefined. Or no slope, okay? A vertical line always has undefined slope or no slope. So those are the 4 different kinds of slope we could run into. Okay?
What's the straight one again? Like
Horizontal line, is that what you're saying? Or this one here?
We just said it's a horizontal line.
Yeah, this would be a horizontal line. Horizontal line always has a slope of 0. And this one would be a vertical line. Another way we can find slope is from an equation. And there's really two go-to equations that we're going to see. Point slope is not really a form that we use a lot in college algebra. You might remember point slope from Algebra 1, Algebra 2. We don't use that a whole lot. Hardly ever will we see point slope form. There might be some scenarios where I kind of show you how to, if you want to use point slope form, if that's something you've used in the past. But slope, intercept, and standard are the two forms for linear equations that we're going to use a lot. So the reminder of those two, and we talked about this in our first lesson. Slope-intercept is y equals mx plus b. Standard form is ax plus by equals c. Slope-intercept is a lot more user-friendly. And I say user-friendly because as I look at my equation, I can identify the slope like that. All I have to do is look at it. It's already in the format we want. I can also identify the y-intercept, and that's what we used to graph the other day. M, once again, represents the slope. Okay? And I'm not even going to worry about the y-intercept today, but the b would be the y-intercept. But because there's an m in that equation, then I already know what my slope is as soon as I look at the equation. Unfortunately, for standard form, it's not quite that easy. I will show you some tricks, some ways that you can find slope pretty easily from standard, but you can't just look at the equation and know immediately what it is without doing a little bit of work. So if I gave you an equation of y equals negative 4/5 x plus 9. Right now, this one is in slope-intercept form. And if I can identify that it's in slope-intercept form, then identifying the slope doesn't take any work at all. M is negative 4/5. And that's it. That's all we have to do. And most of the problems that you do today are going to say, find the slope. So if I have a problem like that and it says find the slope, it's a pretty easy problem, right? Unfortunately, they're not all that easy, but it'd be nice if they were. If I was going to look at standard form. So first up, I'm going to show you how you can find slope from standard form. And then I'm going to show you kind of a shortcut that you can do anytime you have an equation in standard form. So the first one I'm going to give you here is 2x minus 6y equals 12. We have an a, b, and c value. None of those values represent the slope. So what we're going to do here, one way to do this is to change this into y equals mx plus b. We're going to solve for y. So we're going to use some of our algebra skills to get y by itself. So if I was going to solve for y here, what would be our first step? Not yet. Got to subtract first. Yep, we want to get rid of this 2x first. Okay, we want to move this 2x to the other side. So we're going to subtract 2x. Be really careful as you write this out. The negative in front of the 6 is going to stay attached to the 6. 12 minus 2x, we can't combine those together because one's got an x, the other one doesn't. They are not alike. What I typically like to do here is put the x in front. It's not wrong to write 12 minus 2x, but when we write standard or slope-intercept form, we usually put the x in front, okay? And so I think I would rather write negative 2x plus 12 rather than 12 minus 2x, just so it's in the format I can recognize. Okay, now we still try to get y by itself, so we got to get rid of that negative 6. So we're going to divide by negative 6 all the way through. The negative 2 and the negative 6 are going to reduce to be 1/3. 12 divided by negative 6 is negative 2. And the only thing that I'm really needing out of here for today is our slope. Our slope is 1/3. Okay, that's kind of the long way. I show you that way because you can always solve for y and get it in slope-intercept form, but I'm going to show you a shortcut, okay? And once you get this shortcut, I think you're going to like it because it's a lot quicker than what we did just a second ago. So I'm going to give you another equation. Still in standard form. And when it's in standard form, ax plus by equals c, this is my a value, this is my b value, this is my c value. Okay? Here's the shortcut. There's like a little formula that we can, if we can remember this little formula, we can find the slope. So I'm going to put a star by it. Opposite of a over b. That's all we have to know. A right now is 4, but we got to do the opposite of A. So the opposite of 4 would become negative 4. The opposite of negative 5, or sorry, not opposite, but just negative 5. And then negative and a negative make this 4/5. That's our slope. If we go back and check the last one, I could have done opposite of 2 over negative 6, which was 1/3. Okay? And it would have saved us a whole lot of time and wouldn't have to go through all those steps. Okay? But in order to do the shortcut, you got to remember opposite of A over B. That's what gets us to the shortcut. Yep.
They both change?
Because if you take a negative divided by a negative, what's it make? Positive. Yep. So I just divided it out. Or if you have negative on both, then yeah, negatives disappear. A couple of other equations that we could see. And these are more special types of equations. X equals 2 and y equals 3. Audrey?
The bottom one,
Uh-huh.
I had negative.
Okay, x equals 2. So this is another equation. It's not slope-intercept. It's not standard form. It's kind of its own form, right? X equals 2. Well, when I graph x equals 2, we know this is my x-axis. We're going to go over 2. And all that means is that it's going to cross the x-axis at 2. So it's a vertical line. And if I have a vertical line, what kind of slope do I have? Undefined. Okay. So x equals 2 will always have an undefined slope. Okay. Or any x equals anything, I should say. Doesn't just have to be 2. X equals anything is a vertical line. Vertical lines always have an undefined slope. Okay, y equals is just the opposite. Y equals 3 means we're going to go up 3 on the y-axis. This time, it would be a horizontal line. It's going to cross the y-axis at 3. And here's the other thing I kind of remember. This equation doesn't have a y in it. So that means it's never going to cross the y-axis. That's kind of an easy way to remember this. Same thing here. Y is the only variable in this equation. So it's only going to cross the y-axis at 3. It will never cross the x-axis. So that's kind of an easy trick that you can remember when you see those equations. There's no x, so that means it can't cross the x-axis. Okay? And so when I see y equals 3, I'm going to make a horizontal line, and my slope is 0. A horizontal line always has a slope of 0. Okay? Just got to kind of keep those two straight. Easy to get those two confused. Okay, this one here kind of goes back to yesterday. Yesterday we talked about functions, and we talked about input versus output. We said, well, okay, if this is my input, what's my output, and that kind of thing. And that's all we're doing here, okay? They're giving you this right here, and once again, they're asking us to find the slope. I'm not going to keep writing that up here, but I'll keep saying it. What is the slope? But they're giving us some information just a little bit different way, right? And so what we're saying here is if f of negative 2 equals 3, if I evaluate this function at negative 2, it gives me 3. This is my input, this is my output. Okay, another way that I could simply write this is negative 2, 3. That's what we're more familiar with, right? We are more familiar with an ordered pair as opposed to f of negative 2 equals 3. Same thing on the other one. When I plug in negative 1, I get 9. Input, output. And if I ask you how to find the slope, what would be the best way to find slope here?
Formula.
The formula. Yeah, absolutely. Okay. y2 minus y1 over x2 minus x1. Some people might say, well, I want to graph it. Well, if you want to graph it, that's fine, but you're going to probably want a piece of graph paper, and is it available and that kind of thing. You can always use the formula. So we're going to go 9 minus 3 over negative 1 minus negative 2. 9 minus 3 is 6. Negative 1 plus 2 is 1. 6 over 1 is 6. And that's our slope. Okay, the last one I'm going to do here with you is kind of a story problem of where we might use slope or see slope in a story problem scenario. This is number 44 in our textbook on page 70. Okay, so it's given us this scenario, it's given us this situation, and what they're asking us to find is what is the average rate of change and the number of children of a kindergarten class from 2000 to 2022. And they give me some data in the first sentence. Okay, the first thing, anytime we have a data problem like this, like the year that we started with, we're going to refer to that as year 0. So if I started in 2000, and we're going to see this at times throughout the semester, I refer to that as year 0, not year 1, because that's kind of like what we're comparing everything to. So 2000 is what I'm calling year 0. Okay, so my ordered pair here would be 0, 26.3. 22 years later, in 2022, so 22 years later, the number of children had dropped on average to 16.7. So we want to figure out how many students, we know it's a decrease, but we want to figure out how many students, bless you, were we losing per year, okay? That's really what slope is. Slope is a rate of change, okay? And that's kind of like going back to that very first problem that we did out of the table. We talked about the change of y over the change in x. We talked about dividing the two changes. And that's what we're doing here. If I did the slope formula, we're doing the same thing. And so in this case, we would use our slope formula again. Y2 minus y1 over 22 minus 0. Okay, and then when we write our answer here, we would say that we would be losing negative 0.4 children per year, okay? We can't lose like half of a child. I know you might look at, but it's an average, right? It's not, it's based on the data that we've got. So our population in kindergarten is going down a little bit less than one child per year. Okay, so just another way of using slope to represent something, an average or rate of change. Okay. Assignment for today. Today we're going by fours. So that means we're going to start with number 1. Problem number 2 is going to be 5, 9, all the way up to 37. Okay, counting by fours, or adding 4 each time, basically. And then 49 and 55 at the end.